It's a homogeneous mixture of solute and solvent. So the solution is a homogeneous mixture of solute and solvent. Now, when the solvent is water, we call it aqueous solution. Okay? When the solvent is water, we call it aqueous solution. Okay? So everyone can read from the screen? Please ask me if you have any question. I know that my handwriting is not the best. Okay? Please ask me if you have any questions. Stop me and ask me. Now, concentration states how much solute is contained in a given volume or mass of a solvent or a solution, right? So concentration tells us how much solute is contained in a given volume or mass of solvent or solution. So concentration tells us how much solute is contained in a given volume or mass of solution or solvent. Now, concentration can be expressed in different ways. So first we have molarity. And what's molarity?
Moles per liter.
Moles per liter. So it's number of moles of solute per liter of solution. So molarity, number of moles of solute per liter of solution. Volume of solution in liter. Any question? No. What's number of moles? How do we calculate number of
Molar
moles?
mass times all the doubles, or molar mass times the amount of salt we have. Salt used is the word.
Total mass divided by molecular weight.
It's mass of solute divided by molecular weight or molar mass of the solute. So it's mass of solute over molar mass of solute. Any question? We also have molarity, right? Molarity. And what's molarity?
Moles over kilogram of solid.
moles of solute divided by kilogram of solvent. Molarity, and molarity is usually abbreviated by the small letter m, while molarity by the capital letter M. So molarity is moles of solute divided by mass of solvent in kilogram. And please pay attention, it's mass of solvent, not mass of solution. So molarity moles of solute divided by volume of solution in liters, while molarity is moles of solute divided by mass of solvent in kilograms. Not mass of solution, mass of solvent. Mass of solvent. Okay? We have weight percent. Weight percent, which is abbreviated W to equal. Mass of solute over mass of solute divided by mass of total solution times 100. Any question?
Does that say WT or W%?
WT, weight per percentage by weight, because we will have percentage by volume. Okay? WT, percentage by weight. And then we go to a volume percent. Abbreviated by volume percent equal volume of solute over volume of solution times 100. Now, the volume of solute, should it be in milliliter, liters, or what? Does it matter? It's a ratio. It doesn't matter as long as both volume of solute and volume of solution are in the same unit, because they cancel each other. It's a ratio. Yes, please.
So is that the volume of the solute before it's put into solution?
Yes.
Because I know the volume when it comes into solution, its partial volume is different than its.
Yeah, it's the volume of the solute before you place it in the solid. Other questions? Okay, so we also have parts per million and parts per billion. Parts per million and parts per billion. So parts per million is P, M, or small m. It's mass of substance over mass of sample times 10 to the power 6, not 100, 10 to the power 6. Okay? So it's mass of substance over mass of sample times 10 to the power 6 parts per million, sorry. Okay?
Could you give an example?
Yes, we will give examples.
And obviously parts per billion would be 10 to the 9.
That's true. Yes.
When you mean substance, do you mean the solution or do you mean the solvent?
It could be the solute, it could be the solvent. It's any substance. Okay?
Does sample refer to the solution as a whole then?
In case of the solution, it could be an alloy, right? It doesn't have to be solution here. It could be an alloy, like steel, right? It could be a solution also. So, now, we all know that density of dilute aqueous solution density of dilute aqueous solution is 1 gram per milliliter, right? And again, what's an aqueous solution? It's a solution where the solvent is water. So, since the density of dilute aqueous solution is 1 gram per milliliter, we can say every 1 gram of water has a volume of 1 milliliter, right? If the density is 1 gram per milliliter, this means every 1 gram has a volume of 1 milliliter. Okay? This means that every 1 parts per million is equal to 1 microgram per milliliter, and it's equal to 1 milligram per liter. Okay? Every 1 part per million is equal to 1 microgram per milliliter, and it's equal to 1 milligram per liter. Now micro is 10 to the power minus 6. Milli,
-3.
nano,
9.
10 to the negative 9. Okay? Now 1 part per billion is equal to parts per billion is equal to mass of substance over mass of sample. It's parts per billion. We define parts per million, right? Parts per billion. Times 10 to the 9. Okay? Parts per billion. And every 1 part per billion is is 1 microgram per liter.
Per liter.
1 microgram per liter.
That would be the same as 1 milligram per milliliter.
It's the same as 1 milligram per milliliter. It's 1 nanogram per milliliter. Sorry, I said milligram. Nanogram. So I missed by 6 order of magnitude. So it's 1 nanogram per milliliter. Any question about this? Okay. Yes.
I mean, you're defining this as a mass over mass, so I would expect it to be unitless. So I'm kind of confused as to why we have unitless. You know what I mean? You said it's mass of substance over
Exactly, exactly.
But,
The idea here is just like 1 parts per million will be approximated as nanogram per milliliter, and the idea comes from here. And it's only for aqueous solution, and that's why. That's a very good question. Let's talk about 1 microgram per milliliter, right? Microgram is 10 to the power 6, negative 6 gram, right? Now milliliter, we said that every 1 milliliter has a mass of 1 gram. For aqueous solutions, dilute aqueous solutions, every 1 milliliter has a mass of 1 gram. Okay, now if we multiply the denominator and the numerator by 10 to the power 6, this will give me 1 gram over 10 to the power 6 gram. Right? And that's part per minute. It's the same, 1 gram and 10 to the power 6 grams, so this is part per minute. So this is why we approximated 1 ppm as 1 microgram.